Hi, my name is Faraz Masood, and first we'll start the session with the basic particle options and their attributes, how they actually work, and how we can actually utilize them to make effects. So, uh, first of all, I'll give you an idea about how this particle system actually works, what are the variety of ways you can create particles. Uh, Here we have in dynamics menu, drop down dynamics menu, you select the dynamics and you get all the particle options over here. We'll go to particles and create emitter option box. Here we have three types of particle emitter types: omnidirectional and volume. First I'll select the omni, edit, reset the settings and create it with the default settings. I'll create it an omni emitter and I'll go to outliner. If you check out in the outliner, you'll find two nodes, emitter and the particle nodes. Whenever you create an emitter, you'll get one emitter node and one particle node. Emitter will take care of its speed, emitter type and its rate, and particle will basically be taking care of lifespan, what life the particles will be, and color and so on. Particles are basically the small tiny objects which are used to make effects, smoke, fire, etc. And they are pretty much similar to the human beings. Like human beings take birth, live their life, and then they die. Particles are also similar to those. Particles also have a lifespan. They take birth, they live their life, and they finally die. So I'll start with some basic parameters of emitter. Here we have created a basic omni emitter. So here's the basic icon, emitter, and I'll change my time slider to 25 to 5000 so that it plays a little longer. Yeah, when I play, an emitter start emitting the particles, small tiny objects. So we have two node, particles and emitter. I'll select the emitter and go to an option box. Here we have emitter type. In the starting we had three options of emitter type that you can change here also. Here we have two more options. We will talk about it later on. Omni. So if you don't need omni at this time, you can change it to directional or volume, whatever you need or suits you. Omni. Okay, omni is an emitter which emits particle from a single point to uh, the different directions. Like the particle which comes out from a single point, it goes in every direction, like you can see here also. Yeah, the particles are traveling in all the directions. Okay, here we have an option of rate, particles per second. That's a rate for per second, 100 particles per second. Okay, so if I'll play, and if I play for 26 frames, and I just like to know how many particles are presently in my scene. So as the 100 particles are getting emitted per second, so it means 100 particles should be there on a 26 frame. But how will I check it? Okay, I'll go to the particle shape, and here we have an option for count. Here for 25 frames 100, and for the 26 frame it has emitted 4 particles. It means I have 104 particles presently in my scene. Okay, I'll go here and I'll change this value to 500 particles per second, and it starts emitting more particles. The mantra of getting a good effect, good particle effect, is getting a more number of particles. The larger the number of particles would be, the more enhanced your effect would be. But Again, in the last, it depends on your machine whether it's gonna uh, resist the effect or not. Okay, so but the better way of starting with a lower value is always preferable. So rate. After that we'll come to the speed option. Speed is pretty obvious and self-explanatory. If I'll crank up this value, the particles will travel more faster. Right. And we have an option for speed randomness. If I'll make it speed to 2 and speed randomness to 1. So now the some particles will travel faster and some particles will travel slower. It has a little bit of randomness now. And if I make this value to 0, all the particles will travel at a constant speed of 2. See. But how it's gonna work? Like if I want my particles to be of the smaller value of 3 and the maximum value of 6, so how I'm gonna do it? So how actually this speed randomness work is, suppose if I have a value of 2 and if I'll give the value of 1 in speed randomness, so at this time the minimum value of speed is 1 and the maximum value of speed is 3 at this time, because the speed randomness value is subtracted and added to the actual value of speed. So actual value of speed is 2 at this time and speed randomness is 1. So minimum value would be 2 minus 1, 1, and the maximum value would be 2 plus 1, 3. I hope you got it. So here you can work it out with speed randomness. Here we have some more options, but at this time it's not highlighted, like I can't change it. It's disabled at this time. It's because the emitter type, these options are not for the omni emitter. Like if I'll change this to directional emitter, the more and more options will get highlighted, because these options are related to the directional emitter. So it gets highlighted and disabled accordingly when you change your suitable emitter type. Okay. But there are some basic options which are global for all the emitter types, which is rate, cycle, minimum maximum distance, speed, and that's it. Okay, I'll tell you the minimum and maximum distance also. Minimum maximum distance is at this time it's 0. It means when you play, all the particles gets emitted from a single point at the core center of this emitter icon. Yeah. Suppose I don't want this to get emitted from this single point. What I'll do, I'll just work it out with this option, minimum maximum distance. Okay, so if I'll select, the minimum distance should be 2 units. Just make sure it's in units. It's has to do with your grids, and maximum should also be 2. Okay, and I'll play it. See, now it's not getting emitted from a single point, from a center, right? To analyze or to see it more clearly, I'll just make the speed to 0 and play it, and see it's now getting emitted on a radius of 2 units. As it's an omni emitter and it emits the particles in all the directions, it's taking a shape of a sphere. But if you select some other emitter type, it will be be in the other shape. So if I'll say the maximum distance should be 5, so now the particle will be emitted in a distance of 2 and 5 units. It will be more thicker. See, to make it more visible, I'll just increase the number of particles so that we can actually figure it out what actually happening. See, now the particles are getting emitted between 2 to 5 units. Okay, so what you can do with this, the very basic example of using minimum maximum distance is you can make a star field with the help of this. Like if I'll crank this value up to a little higher, like 5000 to the 5000 maximum distance, back and play it, so it will fill the whole area, and at this time you can use it as a star field. You are making a space C like this. Hope you got the idea. Okay, hope you get the idea. Now I'll be going a little faster now. Okay, I'll just change it to directional emitter. Directional emitter is the same as the omni emitter, but it has one different option called, it has got the direction. Like in the omni emitter you were not having a choice of taking the particles into a single direction, but now you have got an option. So if I'll select the directional emitter and make this value a little lower, sorry, not larger, 500, and so here we have got the direction here and play. Okay, it's stuck to the center, it means we have no speed. Okay, with a value of speed 1, and see, it's now traveling into a single direction, and the direction in which it's traveling is, you can edit by here. If you'll say the direction to 0, it will be staying at the same place where it's getting emitted. So it's the same thing. If you have a direction of 1 and a speed of 0, then also it's not gonna travel, and if you have a speed but no direction, it's gonna stick to the same place. If I want these particles to get to the y direction, I'll say the direction y, and now it's traveling upwards, but it's traveling in a single line, right? But might be you don't want these particles to be that much straight. You are making some firecrackers or rocket tie effects or something like that. So with the directional emitter you will get two options. One is for the directions, x, y, z directions. You can make this into a negative value also, like, or the second one is you have an option of spread basically. So if I give it a value of 0.1, see, it's now taking more area, it's getting spreaded. But make sure this value should be a little lesser than 1, because if you make this value to the maximum 1, it will spread to the whole 180 degrees. Yeah, see. So it depends whether uh, you need this type of egg or not. Okay. So that's it for the directional emitter. Okay. So now when you have got the idea of basic emitter option, basic emission options, we'll look out for the particles also, basic particle option. First, uh, what we'll see here is the lifespan attributes. Okay, lifespan mode is by default is live forever, means the particles which are born will never get tired, never die. They keep travel. Okay, but you can end it with your own value. Like we have constant mode here, lifespan 1. This value is in seconds. Like if I say 2, lifespan is 2, it means the particle will emit and be life for 2 seconds only. It will be having a life of 2 seconds. Okay, how will I get to know about it? Okay, so if I play, see, after 2 seconds, after 50 frame, it dies. As all the particles are having a same value at this time, the lifespan of 2, it's dying on this stage. Okay, fine. We can random range the values, mean again the randomization, the kind the same principle which the speed was falling, it's also following the same thing. Lifespan is 2, and how much randomness I want the randomness of 1. So the some particles will die earlier and some will die later on. So at this time you have a little bit of randomness, which obviously gives you a bit of realism. So with the help of this you can make an effect like fire and all. And the last option we have is lifespan pp. If you uh, like to edit the lifespan with the help of mail scripting and ramp, so you can do it with this option also. That's a little bit of intermediate topic. Okay, so I'll make it to random range, it will be fine. And we come down here, we have uh, some particle types, particle render types. We have basically two types of particles over here. One is hardware particles and one is software particles. Basically these are all the types of particles which Maya is providing: multi-point, streaks, numeric. They all have their different usage. uh, but while making an effect, you need to first decide what kind of particles you need: software particles or hardware particles. The particles which are followed by the name SW, blobby surface SW, are the software particles, and rest of these are the hardware particles. Basically the difference is these all particles will be rendered in Maya hardware renderer, and these three particles will be rendered in Maya software renderer. So if you are making any scene, if you are making any effect, and you are using these types of particles, Maya hardware particles, so you have to render it on a separate layer and then composite it into the compositing packages like After Effects, Fusion and all. And if you are making an effect with these cloud, tube and blobby surface, then you have an advantage of mixing them in a same layer. It depends. So we'll go with some basic attributes with or the basic particle types which are generally used. One is point, that's the default one. I'll select the current render type. When you click on current render type, you'll get some more options with this particle type. uh, the basic option over here is the point size. Like here you can increase the point size to 5. See, getting increase. If you have lights in your scene, you can say use lighting also. It will be reflecting on this. And color vacuum basically used uh, for a little bit of illumination, or we can say a little bit of glow, which gives life to the colors of the particles. So we'll look for it later on. uh, Other options we have is multi-point. A single point will convert it to multi-points. Current rendered type, color vacuum we give. Now how many count you need? I'll just say particle type to 2. Here we have how many particles you need for a single point. Like this is kind of a bunch of particles. Suppose like multi count. Here we have multi radius. You can get out. Yes, see. If you like your effect to be more denser, you can use multi-point particles. See, right? Bunch of particles. Same options. Point size. That effect, multi-points, you can use to make an effect like fog and all. And the other which I like the most is the streaks. These are small lines with a little of tail fade effect, right? It's getting faded in the last. So we have line width here. Line width, normal direction, and we have tail fade over here and tail size also. So if we increase the tail size, gets longer. Tail fade, if you don't want any tail fade, you can increase the value to 1, or if you make it to 0, it will be having a fade in the last. Okay, the same thing you can do with the multi-streak, but again now it's having a bunch of multi-streak, a bunch of streaks particles. Same options which we had in multi-point. Current render type, line width, count, multi-radius. Just leave this normal direction. It's a little bit of complicated for now. Okay. uh, Streaks, even we have sprays also. Select 5 in a shaded mode and see. Sprays. So the basic options or the basic particle types which are used to make effects are points, spheres, streak, multi-streak, and multi-points. For the softer particles, you can use cloud and blobby surface. These are the particles which are uh, rendered in softer particles. Like I give you an example with the multi-streak. If I select the multi-streak particles and I try to render it, what happened? It's Maya software, and see, I don't have anything over here right now. It's giving me an error that hardware rendering selected for particle shape, because these are the hardware particles which will not be rendered in Maya software. So I'll select Maya hardware from the renderer settings and I render it. See, now I'm getting the effect. Okay, fine. Now I'll select the particles and change it to the cloud, which are SW, means it's the software particles, and I'll render it with the Maya software. See, it's now getting rendered. Okay, particle which I'm seeing here is the color of the particle which I'm seeing in the viewport is gray, and when I'm rendering it, it's coming a bit of blue, because when you select the cloud particles, cloud is basically connected to the shading node, hypershade. I'll go to hypershade and show you the shading node. And by default, you must have seen this particle cloud node whenever you open your hypershade. So this particle cloud node is by default connected to the cloud particle. Of course you can create your own node, but by default it's connected to that. So here you can change the value of color, transparency and all. So if you select the red color over here and render it out, it will be coming out red. Okay, so as we are running out of time, I'll go a little faster now. Okay, that's it for the basics of these particles. I'll see what more we can do. Yes, of course. Now if you like to change the color of the particles, or you like to play with the transparency of the particle, you have an option here. Add dynamic attributes. You have one option: general, opacity and color. If you want to change the color of your particle, you just select the color, and here it's asking for you how would you like to change your particles or edit your particles to add per object attributes, add per particle attribute and shader. Basically you just understand that there are two ways of editing the particle system. One is per object basis and one is per particle basis. Suppose if you like to change the color of all the particle objects, like you want all the particles to be red or green or in any color, you just select per object attribute. You need to edit the per object attribute. I'll say per object attribute, add attribute. Okay, add attribute, it has become red. I'll select the particle type to be the hardware particle, because the software cloud is already connected to the shader, so this option won't be working on that. So I'll select the multi-streak options and I have already added the per object attribute. Remember, the per object attributes added to the render attributes options. So here when you add the per object attribute, whether it's for color or whether it's for opacity, you'll find that under the render attributes option. So here we have one more options: color red, green, blue. You just need to give it a value. The maximum value is 1, so it goes from 0 to 1. So suppose if I need the red or 0.5, so here you can make your own colors with these values. And I'll go to my hardware and render it. I'll save this out to compare with the other effects, other renders. I'll just select this color recomposition, and the color acume will basically give it a more light or more glowing effect. See, now it's coming out pretty good than it was before. It's looking very flat here, and with the color acume enabled, it's getting more glowing. So it's always better to use color acume with the effects like fires or glowing effects if you don't want your particles to look flat. Okay, so this one is the per object, editing the color on a per object basis. The same ways you can edit the opacity, like per object attribute. I say I want all the opacity of the particles to be of the same value, like 0.5. Now I'll just save it out, render it again. See, or I want this to be of 0.1. See, yeah. So this is editing the particles on a per object basis. But if you like the particles to be of the different colors, like some particles to be the different color and the other particles to be the different color, or same with the opacity, you need to edit the particles on a per particle basis. I'll add the attribute per particle attributes. When you select that, you'll get the RGB PP into the per particle attributes. PP is the per particle, RGB PP, and the very simple way of editing this attribute is just putting a ramp into it, create ramp. Or what you can do is enter a simple mel expressions also, like the color of particles what you like to be, like the particles to be the color of the particles, as it is a vector attribute. You just don't need to focus on it if you don't have any idea about the mel scripting, but I'm just giving you an idea. I want the particles to be of the green color, so let's define. See, now it's coming out in a green color. So this is the first way and the easiest way. If you don't have any idea about mel scripting, you don't need to worry at all. It's a very easy way also, like create a ramp. Right click again and go to edit ramp. Here you have three colors. By default it gives you three colors. If you want the particles to be in a single color, you just delete all this is a simple ramp. Yeah, but one thing you need to be careful of whenever you are using a ramp works on a life, like it starts from here and it ends here. This is the birth of your particles and this is the death of your particles. So I'll just select this. I'd say it should be green at the time of death. So you'll see here the particles are when it gets born it's of red color, and as they goes through the life it's getting green. Hope you get it. So again I go here and I want the opacity to also be on a per particle basis. Here we have opacity pp. Suppose if you have sometimes when you add an attribute you don't get updated here, so what you need to do is just deselect the particle and select that again and you get an option here, opacity pp. I'll just say create RAM. Okay, edit RAM, and by default it will be in a black and white color, that it uses the alpha channel. Okay, so I'll say the particles to be all the particles to be visible, so I'll say the white color, and if I'll say it shouldn't be visible, I'll make it to the black color. Okay, I want the particles to be less visible, so I'll say dark gray, and in the last it should be dye. So now the particles will born, and in the last when it's about to get die it gets fade off. Okay, so these are some basic options for particles, emitters and particles. So now I just have one more option to tell you, and then we'll give you a small idea about how you can make an effect like this, a fire ring, like very basic effect with the common attributes. See, yeah, just in 5 minutes. Okay, so I'll just tell you one more option. Suppose if I'll make a surface plane and I want the particles to get emitted from this surface, so I'll go to particles, and we have an option for emit from all. If you want the particles to get emitted from any surface curve or like that. Okay, so you just need to focus when you are getting the particles from your surface, then the emitter type should be the surface, otherwise it won't work properly, or it will not be working as you thought. So I'll say surface create on a default options, and when I play the particles are getting emitted from the faces of my plane. Okay, why did I select the surface? If I wouldn't have selected the surface, then what would be the result. Okay, if I select the omni emitter, it's getting emitted from an object. See, particles are getting emitted from the single point, all the vertex of the plane. In the same manner, if I select this to be the directional and the directional to be in the up direction, see, it's getting emitted from the all direction, but I don't want that. I want the particles to get emitted from the faces, so I need to select surface from here. Okay, see, okay, so I'll go to particle. I'll change the particle type from points to sphere, reduce its size, and one thing which I want is I don't want particles to travel in any direction. I want that to be at the place where they are born. So simply I'll say speed to 0. So they'll just stick to the place where they are born. Okay, but I don't want these particles to continuously emitted. I just want that particles to get emitted for a certain period of time, or I just want the 20 particles to get emitted and no more particles after that. So what I can do is I can uh, key this rate option, or the best way to do that is I'll go to particle shape, and here we have an option for maximum count. If the maximum count is -1, the particles are emitted, like the particles will get emitted infinitely. There are no limits of the particle, but if I know that I just want these particles to be of this value, like I want only 25 particles in my scene, no more particles after that, so the particles will get emitted to 25 and then it will stop emitting the particles. Okay, I just need the 25 particles, and I'll come to the speed now. Here we have an option for directions. See, I have applied image from object surface option here, and I'll come to here. In the surface option, we have two more options get enabled here, which are tangent speed and normal speed. If I'll make the speed to normal, like 1, it's going to the up direction. Alright, just because the facing side of this is this one. We don't have any direction here, but still it's going in the up direction. Okay, I'll just check it out. If I'll rotate this and play this, in which direction it goes. Oh, it means they are going into the facing direction of this object. If it's rotated, it's going in this direction. If it will be on a different side, it will be walking as that. I'm really sorry for this disturbance, as some construction is going, so I'm really sorry for this disturbance, and I mean it. Okay, so we have an option. Select this particle. We have an option here for normal speed. Normal speed is basically the option which takes the particles to the direction where the normal of the polygon is. It's the facing side of this object is here. It will be going in this direction. If it's not, it will be going in a different direction. So if I'll crank this up to 0, or I'll just change this value to 0, it will be staying at the same place. But if I'll change this value to normal speed to -1, it will be going in a negative direction. Simple. And if I'll take this speed to 0, if I'll say we have no speed but a normal speed of 1, it will not travel. So it actually, when you are working with the surface emitter type, it actually tells you the direction, the positive or the negative direction, normal speed. If I'll say the speed to be the 5 and normal speed to 0, it will stick to the same place because it has no idea in which direction it should go, to the positive direction or to the negative direction. It gets confused. So that's what the normal speed does. We have one more option called tangent speed. See, we have normal speed 0, speed randomness is also 0, and I'll just say speed to 1. And what I'll do, I'll just give it lower value of 0.1 into the tangent speed, and when I play it, it starts running to the surface. It's traveling with the surface, like the direction of the surface is what tangent speed does. It starts to run along with the surface. See, but if you have no speed but higher tangent speed, it has no effect. To run the tangent speed, you need to have a bit of speed here. Let's say 2. With the higher tangent speed, it will run very faster, travel very faster. So this is what travel tangent speed does. If you are making a long shot with a kind of cockroaches running into the kitchen or something like that, so you can simply make that. So I hope I have covered some basic options, and now it's time to tell you something. It's time to utilize these tools and attributes to make a small effect. So what I'll do, I'll create a nerve circle here. I'll create a circle, and I'll go to particles. I want the particles to get emitted from this circle, so I'll emit from object. I'll change this to curve, emitter type to curve, and rate, set this to 100. Create. Let's play. Particles are getting emitted. Okay, fine. I'll go to the emitter, and I'll say particle type curve. I didn't tell you the type emitter curve type, but that's the same like the surface emitter, but the surface works on polygons and nerves, and it works on curves. That's it. That's the difference. All the attributes are the same. Okay, so I'll come here and I'll say I don't want these particles to be traveling in a x direction, so I just say 0. See, whenever you're working with the surface and you will find this direction, just make sure whether you want these particles to be traveling in that direction or not. See, it's going in up direction. If I'll say no, I don't want any direction, then it will be going in all the directions. Okay, that's fine. I'll work with that. That's not a problem. I have speed. I have normal speed of 1. One thing I just like to tell you before making an effect is whenever you are making any effect you are making, you need to focus on the simulation first. How you like that simulation to be, how the particles should behave. If you are making a fire, then the simulation should be looking like a fire. If you are making a water, then the particle should flow like a water. So the first thing what you should take care in your mind is the simulation. You just need to simulate the effect like what you need or what the client needs, and after that you can work on the particles and the look of the particles, how real you want that. So first I like to make a firing. So first we'll uh, go for the simulation, and first we'll enhance or make the simulation how we need, then we'll go for the look of the particles. So I want the particle type to be multi-streak. I think this would be great. Tail size, I say 5, and or I'll go with streaks right now. I'll go with streaks, okay. And with the random range, I'll just see how this should go. mm, for now it's good, but I'll say like 0.8. I don't want that to go that far. I'll come to the emitter and I'll say I need more particles this time, maybe 500 particles. Okay, but I don't want this to go that far. If I'll say the normal speed to 0, it would be like this, and if I'll say it should be 0.2, it's going like this. Alright. Okay, I want these particles to get rotate on this surface, like it should travel on this surface. So in the last example, what we did was the tangent speed helps the particles to go or to travel on a surface. So what I'll do here is I'll crank this value up to 0.5 and see it imitates the effects like it's rotating. What you can do, what other you can do is you can rotate this circle, or you can key this circle emitter like this way, and it will work the same, but I don't want that. So it imitates like it's rotating, and at this stage I just like to be I want my particles to get more faster. Okay, at this stage I'll go into the particle shape and I'll select the multi-streak instead of this streak, so that it fills my area. And let's see. I don't want my particles to get just 0.25. I just do a bit of speed randomness. I give it a bit of speed randomness so that, and I want my particles to be to live for a little longer. Not that much. It requires a lot of patience. I think it should be 0.2. Okay, fine. And I just increase this value curve. Okay, that's good for me. And now I'm satisfied with the basic simulation, and now I'll just like to work with the color. So what I'll do is I'll add a per. I don't want the particles to be of the same color, so I'll add the per particle attribute here, and simply I'll just create a ramp. And okay, I want my first color to be yellow, and second a bit of orangish, and the last I want that to be gray one. Alright, let's see what's coming out. Alright, fine. I'll add an opacity also, and in opacity I'll simply create a ramp, and as I said, black color means no opacity and white colors mean opacity. I want the particles to be transparent when it gets burst, so I'll say no. I select this one and say no transparency, and this one, and in the middle it gets full opaque, and then again it gets transparented. Alright, it gives it is giving a fee. Okay, fine, but it's not coming out glowing, so I say color vacuum. Alright, I just want this. Just like to see how it's coming out my hardware. Okay, I'm on particles, but I just save it into the F direction. Maya. Okay, lecture 1. This would be the firing 2, I will say. Okay, this time I can increase more number of particles to increase my effect. Okay, when you render it out, it's coming out pretty good, I believe, but it's not what I want. It's coming out very sharp, and you'll be able to analyze these are the small lines which are coming out. It's not looking like fire at all, but there are a number of ways to increase the realism of your effect or your look. So I'll tell you one good way in Maya. So we'll go to window, rendering editor, and hardware render buffer. Here this render buffer is especially for the hardware particles, and you can simply render it out and see what how your particles are looking at this time. And we have an option, some extra options, also some extra attributes. Go to render attributes, you'll find some good options over here. So if you like to render and see how your particles will look for in 300 frames by frame 1 Chaga. Okay, just I'm not be going into that much detail, but I'll tell you a good option here to increase the look of your particles. So here we have this very sharp looking particles, and I just like to smooth it out a bit. So here we have an option, multi-pass render option. So enable this option, and you have an option here for render passes and some values here. So I'll go with the first one, C, and as you will increase the values, it will smooth out the effect. I believe 16 and 25 would be better. So it depends on your system and your kind of look which you want. See, so if I like this, if I say okay, 25 is better, and I just like to see how my particles will look like. So what you can do, you can just you want a test render, so you just define what number of frames you need and go to render sequence. It will take a little time, and then you will able to see how your particles will gonna look after render. So we need to wait for a sec. Alright. Okay, so once done, you'll go to the flipbook and you'll find your test end over here. You just click this option and you'll be able to see the simulation and the look, how it's gonna look after that. So I hope you liked this session, and that's it for now. Goodbye.